Imagine that I ask you to tell me which are the most important airports around the globe, or who is the most popular among your friends. So you may tell me, okay, but I need a metric of popularity or importance. In networks terms, this translates into the concept of centrality.
Bartolucci and her co-authors devised a theoretical approach to compute a benchmark for centrality, a common measure used in networks. These complex networks include transportation hubs, financial markets, and human neural networks.
An obvious way to compute centrality is just to count the number of connections that you have. For instance, how many flights are coming in or out of an airport. But is this the full story?
To find this metric, instead of counting just the number of connections or nodes, they focused on calculating the full probability distribution of Katz centrality, a more sophisticated measure of relevance of these network nodes.
At the very start of the pandemic in 2020, we started working on a series of projects on assessing centrality in networks. What we did, for example, was to look at small regional airports that may be underlooked because they are maybe relatively small airport that still show a higher than expected centrality. Why? Because this location may be tourist small airport, but they have critical connection with Europe or the US. And so local disruption would impact and cascade across the global network.
During a work session, the team realized that they could apply the cavity method, a mathematical technique developed in the 80s, to the problem of calculating the distribution of centrality in networks.
We thought, okay, but this methodology, we can actually apply to our problems with the centrality calculation because it allows to compute similar objects in an efficient way that is also mathematically tractable. So we started doing the computation, the draft of the calculations, and we were really pleased when we saw the theoretical curve matching our simulations. And so our calculation worked. One of the interesting achievements that we got is really the characterization of this distribution of centrality given information about the local connectivity. So now we have a tool to look at our empirical networks and determine whether what we observe is something important, something that we should keep an eye on.